Hello students. In today's class we are going to discuss about identity element of a given set with respect to the given binary operation. Now, when we say an element of a set G is an identity element, if for every element of G, if this satisfies A star E, where star is a binary operation, A star E is same as A, or E star A is same as A. So whenever you operate every element of G with E, you should get same answer A. So A star E is equal to A, as well as E star A is equal to A. Then we say E is the identity element of set G. Then you know that for the set of finitely many elements, you have to construct a Callis table, and in the Callis table, you know that there are row headings as well as column headings. See which row heading is same as the topmost row. Then that row heading will be the identity element of that given set or group. Now, to understand this, let's see a problem. Find the identity element of the following sets with respect to the given binary operation. The first set which we are given is Z5 under addition modulo 5. Z5 consists of 0, 1, 2, 3, 4. So finitely many elements. Now let's construct a Callis table. Binary operation is addition modulo 5. You know how to construct the Callis table. You have to write all the elements of Z5 in the topmost row. In this row, this is topmost row, 0, 1, 2, 3, 4. And you have to write all the elements of Z5 in the leftmost column. This, remember, this is first row, this is second row, this is third row, fourth row, fifth row. These are row headings. 0 is the row heading of this, 1 is the row heading of this, 2 is the row heading of this, 3 is the row heading, 4 is the row heading. This is column heading. First column heading, second column heading, third column heading, fourth column heading, fifth column heading. Right? Now, what is your condition for verifying the identity element? You should get A star E is equal to A, or E star A is equal to A. Now, here your star is addition modulo 5. Then your binary operation will be, your condition will be A addition modulo 5 E will be equal to A only. So what is the condition? A addition modulo 5 E is equal to A. Instead of star, you have to write addition modulo 5. Now, from where your A has to come? A will come from this set Z5. So A can take 5 values. So A may be 0, A may be 1, A may be 2, A may be 3, A may be 4. So you should note that you should get A addition modulo 5 E will be equal to A only. And from where your E should come? E also should come from the same set Z5. So you have to see that A addition modulo 5 E is equal to A, where A and E comes from Z5. Now let's give a value for A. Let's say A is 0, right? A is 0. Then A is 1, A is 2, A is 3, A is 4. So this is A, 0, 1, 2, 3, 4. Then by adding E with A, you should get A only. Under addition, you should note that 0 is one such element which gives 0 plus that element is 0 only. That's why I had given instead of E is 0. 0 is present in this. So your E is 0 in this case. Your E is 0 in this case. Why? Because it satisfies 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 under addition modulo 5 is 3, 0 plus 4 is 4. So similarly, as you know that A star E is same as E star A. So I had given E star A. Now I'll write A star E. A is 0, E is 0. So 0 plus 0 is 0. A is 1, E is 0. 1 plus 0 is also 1. 2 plus 0 is also 2. 3 plus 0 is also 3. 4 plus 0 is also 4. So left and right identity laws both are holding. One is right identity law, another one left identity law. Both are holding, and your 0 is the element which is satisfying this. Therefore, 0 is the identity element. That is, it is satisfying A. Addition modulo phi 0 is A. You can easily see that from the table. See, you have written 0 plus 0 is 0. That is here, 0 plus 0 is 0. 0 plus 1 is 1. Yeah, 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 2 is 2. 0 plus 3 is 3. 0 plus 3 is 3. 0 plus 4 is 4. 0 plus 4 is 4. Now, see this row. This row is same as the topmost row. This row heading 0 is same as the topmost row. Therefore, this row heading is the identity element. This is how you can identify in the case of finite sets. So in the case of finite sets, the row heading which is same as the topmost row will be will be the identity element. So since this row is same as the topmost row, this row heading 0 is the identity element. So instead of writing all these things, simply while solving the problem, you can see which row heading is same as topmost row. If there is any row heading which is same as the topmost row, then you can write the row heading 0 is same as the topmost row. Hence, 0 is the identity element. This much is enough to find the identity element. Then, how to write this one in Maxima? Very simple. So, as usual, first I'll write kill all to kill all the temporarily stored values. Then I'll call this set. What is your set? Z5. Simply I'll write Z. What are the elements of the set? Since it is a set, I'm writing within flower bracket 0, 1, 2, 3, 4. I don't want to display this. I'll put a dollar sign. And we should have a binary operation. So what is your binary operation? Addition modulo phi. So I'll call that one as BO, binary operation. You can give any name. I'd given BO. BO of XY. I'll assign this one as a function. So I have to use colon with equal sign. This assignment is set. It is not function, but this is a function. So BO of XY, colon with equal sign. I want modulus. I'll add X and Y, and I'll apply modulus with respect to phi. So mod of X plus Y with phi. Put a dollar sign. Then I'll call E as some unknown X. You might wonder why I need to call this one as some X. I'll tell you at the later stage. Now just you give anything for E. I had given E as X. But remember, whatever the value that you give here, you should remember that. So E is X. I don't want to display this, so I put a dollar sign. Next, as usual, I have to verify by term wise, right? I have to check. See, this is your I. So I takes from 0, 1, 2, 3, 4. I, J. J is this column. J takes value 0, 1, 2, 3, 4. Right? So if you want to say 0 is the identity element, you should note that I plus J should be equal to J. 0 plus 0 is 0. 0 plus 1 is 1. But 1 is your J. So this is J. 0 plus 2 is J. 0 plus 3 is 3, which is J. 0 plus 4 is 4, which is J. So if it satisfies I plus J is equal to J, or J plus I is equal to J. See, if you call these as J, then 0 plus 0, 0. What is, where it is? 0 plus 0 is 0. Then 1 plus 0, 1. 2 plus 0, 2, 3 plus 0, 3, 4 plus 0, 4. So you should get the same thing. So your I plus j is equal to j, as well as j plus I is also equal to j only. Now that I'll write. So for that I'll give values for I in j, I in z do. For I in z do means I will take all the values of z starting with 0. And since I'm writing this one in a loop, I've put a simple bracket. You should use only simple bracket. Now I'll call a temporary variable as flag. Flag is assigned with 1. So I'm assigning the value flag as 1. That means it is true. Right now your flag value is true. Now I'll give the value for j. For j in z do. That means you have to give all the values for j in z. Starting from 0, 1, 2, 3, 4. As we know how to evaluate the loop, as I've explained, you know how to evaluate the loop as I've explained in the previous programs. By the same way it will run. First I will take 0, then j runs for all the values starting from 0, 1, 2, 3, 4. Right? Then it verifies the condition. If binary operation of I and j is not equal to j and binary operation of j and I is not equal to j. Remember, BO of ij is nothing but this, that is BO of xy is mod x plus y with phi. So BO of ij is I plus j with respect to modulo phi. You remember, I plus j should give you j because I want to find the identity. If I is the identity, then it will equal to j. And binary operation of j and I, that is j plus I modulo phi, should give you j only if I is the identity. If they are not equal, then I is not an identity. I is not an identity. So that's why I put flag as 0 if these two are not equal. If these two are not equal, then flag is false. So flag will assume 0. Flag will assume what? 0. Remember, don't forget to put comma because it is a continuation statement in the loop. So if this is true, then flag will assume 0, comma. If flag is equal to 1, then E is I. E will assign the value with I. Remember, a flag is 1 when this is not true. Not true means BO of ij will be equal to j and BO of ji will be equal to j. If this is true, that is this is not equal to j and this is not equal to j, then flag is 0. Then when will be the flag 1? Flag is 1 when this is not true, that is BO of ij is equal to j or BO of ji is equal to j. Then flag will be retained with 1 for that I. So if flag is equal to 1, then E will take that I value. Now let's see by giving values for I. Say suppose I is 0, then flag is 1. J will take initially 0. So J is 0. Now we'll go to this condition. BO of 0, 0. 0, 0 is 0 plus 0 modulo phi, which is equal to 0. This condition is failing. 0, 0 is equal to 0 and BO of 0, 0 is equal to 0. So this is failing. Then flag is what? Not 0 because it is failing here. That means flag will be 1. Flag will remain 1. Now if flag is 1, then E is colon. E will be assigned with what value? 0. E is 0. So E stores the value 0. Now again it goes back. Now j will take 1. Remember your I is 0. 0 will not change now. J will take 1. Then now it comes here. BO of 0, 1. What is 0 plus 1? It is 1 only. That is j only. And BO of 1 plus 0 is 1. So it is giving you the value opposite of this. Therefore, flag will remain 1. Flag will remain 1. Remember, flag is 0 only if this is true. But this is not true here. So flag will remain 1. If flag is 1, then E will store the value of I. What is your I? I is 0 only. I is not changing. Then it comes back again here. Now for J, after 0 and 1, now we'll give 2. 2. Then if BO of 0, 2, what is 0, 2, BO of 0, 2? By this, it is modulus of 0 plus 2, 5. 0 plus 2 is 2, which is less than 5. So it gives you 2 only. So it is 2. So your 0, j, BO of 0, j is equal to j only. That is 2. So this is not true. And BO of 2, 0 is 2. So this is not true. Here it is not equal to, but we are getting equal. Therefore, flag value is not 0. It is 1 only. Flag will store 1. If flag is 1, then E is colon I. E will store the value of I. What is the value of I? It is 0. That will store. Now again it comes back here. We had given J 0, 1, 2. Now it takes 3. If see 3, then 0, 3, BO of 0, 3. What is 0 plus 3? 3 only. So we are getting J only. And BO of 3, 0, which is again 3 only. So we are getting equal sign here. Then flag will be 1, not 0. Flag will remain 1. It will not change. So if flag is 1, then E will be stored with I. What is your I? 0. Again it comes back here. J takes now 4. BO of 0, 4. What is 0, 4? That is 0 addition modulo 5, 4. 0 plus 4 is 4. Which is again J. BO of 4, 0. Which is again 4. Which is J. So this is not true. Therefore flag will remain 1. If flag is 1, then E will store the value I. What is your I? 0 only. Now it comes back here, but J has already taken all the values 0, 1, 2, 3, 4. So it comes back here, back to this. Now it says flag as 1. It will set flag as 1. Now remember your E is stored right now with value 0 after the first loop, right? Now it comes here and I will take 1. Earlier I has taken 0, now it takes 1. And it comes back here, flag will be stored with 1. For J in Z do if, now which value J will take? 0. It starts from 0 only. But remember your I has taken 1. So your J is 0. Now I is 1. 1, 0. That is 1 plus 0. What is 1 plus 0? 1. So it is not equal to 0. Your 0 is J. So it is not equal to J. And BO is J, I, which is not equal to J. That is 0, 1 is not equal to 0. Therefore, flag will retain with 0. Because this is true now. Your I is 1, J is 0. Right? 1 plus 0 is 1. But you should get answer as J. But you are not getting J. Therefore, this is not equal to J. Therefore, this is true. And 0, 1. What is that? 0 plus 1 is 1. But that is not equal to 0. Therefore, B of this is not equal to 0. This is also true. Therefore, flag will be stored with value 0. Now, what is your flag value? Your flag has stored 0. If flag is 1, then E is I. But here your flag is what? 0. So it will not execute this. It goes back here. Now J will take 1. Remember, I remain same till the completion, till j takes all the values of z. Right? Now j will be 1. Now BO of 1 comma 1, that is 1 plus 1 modulo 5. What is 1 plus 1? 2. Right? So this is 2. So this answer is 2. But what is your j? 1. 2 is not equal to 1. Therefore BO of this is not equal to j. And similarly this. Therefore flag will be stored with 0. Since flag is 0, this will not be executed. Now it goes back here again. So j takes 2, j takes 3, 4. It goes on, proceeds, and everything will give you flag as 0. Once after completion of this, it comes back here again. Now I will take 2. Earlier we had given 0 and 1. Now I will take 2. I will take 2 and flag is stored with 1. Again j will take all the values, but remember, none of them will give you this. Therefore flag will be stored with 0 only for all of them. Then again it comes back after completion of the cycle, and I will take 3 and j will be given with all the values. Again these will be failing. Again your flag will be 0. If flag is 0, none of this statement will not be executed. So E remains same. If flag is 1, then only E changes. But here flag is not 1. Flag is becoming 0 in all the case. So E will be stored with the first value, that is 0. That is not changing. This will run till I takes all the values. I takes all the values of Z. Once after completion of this loop, it comes out. Now it comes here. Remember, your E has stored 0. E has stored 0. Suppose there is no identity element exists, then E will not store anything. E will be simply empty. So that's the reason we have used X in the beginning. We have assigned E with some predefined value X. Right? Now, what's your E value after execution of this loop? E is 0. But what is the value that we are given for E? X. So once after execution of this loop, if E changes, that is identity exists, then E surely will have different value. E will have surely different value, not the X. So if E is not equal to X, then print the identity element is E. Right? Else print the identity element does not exist. That means if your E retains X only, if E is equal to X only, then identity element does not exist. If E takes any other value other than X, then surely identity element exists. This is how you have to run the Maxima code for getting the identity element of a given set. Now I had given another example for multiplication modulo 10. As usual, you construct the Callis table, multiplication modulo 10, and write all the elements of the given set 2, 4, 6, 8 in the topmost row as well as in the leftmost column. Multiply them and apply modulo 10. Now see, this row is same as topmost row. This row is same as topmost row. Therefore, this row heading 6 is the identity element. Why? Because 6 into 2 is 2. 6 into 4 is 4. 6 into 6 is 6. 6 into 8 is 8 under modulo 10. That is giving you E into A is equal to A only. Similarly, A into E is equal to A only. That is what I have written here. A into E is equal to A. See, I had given value for A 2, 4, 6, 8. E is 6. If you apply the binary operation, you will get the same. So since this row heading 6 is same as topmost row, the identity element is 6. This much is enough, right? No need to write all these things. But just to show you in 3 examples or 2 examples I had written in the next problems, the problems which are given, simply you can write this much. See which row is same as topmost row. That will be the identity element. because that satisfies the condition A star E is equal to E star A is equal to A. Right? So what is meant by identity element? When you operate any element with that identity element, your answer is that element only, not the identity element. Your answer is that element only. So here I am operating this element A with 6. I am getting an answer as A only. A into 6 is equal to A. A into 6 equal to A. A into 6 equal to 6. That is A. A into 6 equal to A. That's how you have to identify the identity element. So Maxima code is same. Only thing, I have to change the set and binary operation. Remaining thing works in the same fashion which I explained in the earlier problem. Right? Remember, I've called E as some unknown X. Whatever you call here, same thing you write here. If I put some B, say E is B, then E is not equal to B, then print identity is, otherwise the identity element does not exist. That's how you have to write. Now in the next problem I had given 2, 4, 6, 8, 10 and the binary operation is addition modulo 12, not 10. This is 2, 4, 6, 8, 10 and addition, multiplication modulo 12. See, is there any row which is same as topmost row? No, none of the row is same as topmost row. That means this has no identity element, because there is no single element which gives you A multiplication modulo 12E is equal to A. Suppose if I give A as 2, 2 into which element gives you 2? None of the element gives you 2. See? None of the element is giving you answer as 2. Therefore, A into E is not equal to A in this case. A multiplication modulo 12, E is not equal to A. But few elements are giving you A into E equal to A. But our condition says all the elements should satisfy that condition. See here, 4 into 4 is 4. So A into E is equal to A here. Here also A into E is equal to A. But for this element it is failing. There is no element which gives A into that element is equal to 6 only. No, answer is 6. But this element is satisfying this condition. A into E is equal to A. But this one also doesn't satisfy that. So when you say some E is the identity element, it has to satisfy for all the elements. Therefore, there exists no identity element. Write the program in the same manner. Only thing you have to change the set and the binary operation. Remaining thing is same. I'd given some examples and also I'd given some problems. You work out them and write them as assignment. Okay, now let's execute the Maxima program. As usual, we'll start with kill all. Then the first problem, what was your set? It was Z5. So I need to enter the elements and let's assign this one to Z. So this is our given set. I don't want to display this. So let's keep this one with the $sign. Then what was your binary operation? Your binary operation was modulus of x plus y with 5. I don't want to display this, so I'll keep this one as it is. Now after this, what is the next step that you are having? I told you that we'll assign some unknown value to, unknown x to E. Then now we have to construct the loop for I in Z. Do what it has to do? It has to do this. Let's give a value flag 1. I'm assigning it with 1, and since I'm having a continuation line, I'm using comma. Then now give a loop for j. For j inside, do, yeah, what it has to do? It has to verify whether binary operation of I comma j is not equal to j and binary operation of j comma I is not equal to j. If this is true, then flag will change with 0. Flag will change with 0. And further, if flag is retaining with 1, remember you have to call the value. So I should not use assigning. So I have to call that flag is equal to 1. Then I need to give the value for E, which is I. And I have to stop this. So since there is no continuation line, I'm not giving comma. So just I'll stop by using $sign. So now this executes the loop. So this will execute this loop. Then afterwards, if E is not equal to X, then it has to print the identity element is E equal to, I'll put a colon. This is non-executable statement because it has been given within double quote, comma, value stored in E. Suppose if not, then print the identity element does not exist and stop the loop. Now let's execute this program as usual using shift enter. Yeah, it has executed and it is showing that the identity element is 0. I don't want this colon, so I'll remove that. Yes, identity element is E is equal to 0. So similarly we can execute all the programs. Let's execute one more. I'll copy down this and I'll paste it. So what was your second problem? The second problem, Z was, you can give any value, any name for this, G or Z, doesn't matter. It is 2468. So it is 2468. And what was your binary operation? It is multiplication modulo 10. Multiplication modulo 10. Okay, remaining thing will be the same. Execute this and see what you're going to get. Yes, as we have solved manually and we got the identity element is 6, but the same is here. It is giving you the same answer, right? So this is how you can write the Maxima program. Thank you.